Okay, this question is about emission, hydrogen emission, emission of photons from the hydrogen spectrum. It says determine the energy of a photon of blue light, which is this one here, 435 nanometers, emitted in the hydrogen spectrum. Okay, so for this, you just need to remember or look in your data booklet that the energy is HF, or in this case, HC over lambda, because we're talking about wavelength instead of frequency. Then you just need to put your numbers in. So 6.63 times 10 to the minus 34 times 3 times 10 to the 8 divided by the wavelength, which is 435 times 10 to the minus 9, gives you 4.57 times 10 to the minus 19 joules. Identify with an arrow labeled B on the diagram the transition in the hydrogen spectrum that gives rise to the photon with the energy there. Well, it's got to give out the difference in the numbers here has to be 4.57 times 10 to the minus 19. There's no way that it could be falling down to this one because that wouldn't be anywhere near enough energy. So it must be falling down to 5.44. So we just need to do 5.44 minus 4.57 because that's what we've got here, and that gives us 0.87, which is this one. So the arrow must be down there, and it said labeled B, so you've got to label it B. Explain your answer. Well, to explain the answer, we've just got to say that it's emitting a photon, so the energy has to decrease. The energy of the hydrogen has to decrease. So photon emission requires a decrease of energy of the hydrogen. And the energy of the photon has to correspond to the amount of energy lost. There we go.